All right, in the last couple videos, we looked at being able to find the 5-number summary and being able to create a box and whisker plot. So in this video, we want to be able to interpret or read the data in order to read the box and whisker plot, and maybe what does that mean, okay? Now, with the construction of a box and whisker plot, we broke it into quartiles, Q1, Q3, the median, the middle value. So that breaks it up into fourths, okay? So we really have 4 different parts here. From the least value to Q1, this contains 25% or a fourth of the data within that whisker. Okay, then in the upper value, the greater value to Q3, in this whisker, we also contain 25% of the data. Now, within the box, however, from Q1 to Q3, that's where the inner half or the inner 50% of the data is contained, with Q2 being the middle value. Okay, so half of the data, the inner half of the data, is contained within the box, and then each whisker contains a fourth or 25%. Okay, now, one thing that they might talk about is the interquartile range. Okay, we talked about range before. We take the greatest value minus the smallest value, and that gives us the range of values within the variation of the data. Okay, well, the interquartile range is very similar, except it talks about how much does it vary within the innermost 50%. Okay, from Q1 to Q3. So in order to find the IQR, or the interquartile range, they take Q3 minus Q1. So they're just checking to see how much do things vary by within the inner 50% from Q1 to Q3. Okay, now with that in mind, we can take that information, maybe look at a given situation, and interpret what does it mean. So they give us a box and whisker plot here, in which this represents in seconds the songs played by a rock band at a concert. Okay, so they're talking about in terms of length in seconds. If they were to look at various different bands and the different songs that they played, how long was each song in terms of seconds? Then if we take the data, find our 5-number summary, and create a box and whisker plot, this is what we would have. Okay, so notice the smallest value here is 160 seconds. The largest value is 300 seconds. The median, the middle number, is 260, Q1 is 220, and Q3 is 280. Okay, so that all represents the length of a song in terms of seconds. Okay, now the first thing they tell us to do is find and interpret the range of the data. Well, the range would be the largest value minus the smallest value, 300 minus 160. Okay, so we take 300 minus 160 and we get 140. Okay, so we get 140. Well, what does that tell us there? Well, that tells us that in terms of all the different songs in terms of their length that they were played, they don't vary much more than 140 seconds. Okay, now in terms of the distribution here, how things are weighed out. Well, remember, 25% of the data is located in this whisker. Another 25% of the data is located in this whisker. Okay, so 25% on the lower end of things doesn't vary much more than by 160 to 220. And then 25% of things on the upper end doesn't vary much more than by 280 to 300. But the great majority, the 50% in the innermost, most of your songs in the inner 50% are somewhere between 220 seconds to 280 seconds. So most of the songs that they heard occurred between 220 seconds and 280 seconds. Okay? Now, they also ask us to find and determine the interquartile range of the data. So remember, to find and determine the interquartile range of the data, what they're talking about is finding the range within the innermost 50%. So we have to take Q1, which is 220, and then we have to take Q3, which is 280, okay? And we're going to subtract those values. So we take 280 minus 220, and we get 60. In other words, the great majority of the 50% of the songs located within our box don't vary much more than 60 seconds. Well, 60 seconds is a minute, so that just means a great majority of the songs within the innermost box, they don't vary much more in terms of length more than a minute. Okay, so they're not much more than varied by a minute apart there, okay, in terms of length. Okay, now, are the data more spread out below Q1, so they're talking about, is it more spread out here, because Q1 is right here, or is it more spread out on the upper side there? okay? And then kind of explain what does that mean, okay? Well, when we're looking at the box and whisker plot, wherever the whisker is longer, that's where the information is more spread out, okay? That's where there's maybe possibly less data and things are slightly more spread out. So it's actually more spread out on this lower end from Q1 to the least value here. Where it's more concentrated, where more songs, where most of the data is concentrated, is in this upper half here, okay? So more of the data is closer together right there. Okay, and this actually leads to a distribution of how we can look at the distribution of the box and whisker plot, which we'll see here in a second. Okay, and this actually just kind of confirms what we were talking about earlier here. Okay, so we said the least value is 160, the greatest value is 300, so that means the song lengths didn't vary much more than 140 seconds. We talked about how the whisker contains 25% of the data, the box contains 50% of the data. We talked about the variation of the interquartile range. And then just like we said there, the left whisker is longer than the right whisker. So this is what I was saying. The left whisker is longer than the right whisker, which means Q1 would be more spread out, okay? Now, the reason for that, we can think of it, is because of this guy right here, okay? So that's what I was talking about. Depending on how the box and whisker plot turns out after we constructed it, it could look like one of these three situations here, okay? In which case, if we would call this guy skewed left if the left whisker is longer than the right whisker, okay? So if the left whisker is longer than the right whisker, that would be skewed left. In other words, most of the data is on the right side of the plot. So like I was saying, that means most of our data is concentrated right in here on the right side of the plot, okay? If it looks more symmetric, in other words, the left whisker and the right whisker look about the same, okay? The whiskers are about the same length, and that means the median should be pretty much in the middle of the plot. Now, if it's exactly symmetric, it would be exactly in the middle of the plot, okay? But in terms of, since everything doesn't always turn out nice, in general, if it looks pretty symmetric, the median should be pretty much in the middle of the plot. Okay, now if it's skewed right, that means the right whisker is longer. Okay, so if the right whisker is longer, then it's skewed right, and that means most of the data is on the left side of the plot. Okay, so we have more of a concentration of data on the left side of the plot down. Okay, so that's kind of how to read a box and whisker plot. Kind of understand what is that indicating. Like we said, it would be more spread out here, and then we'd have a higher concentration of data here. Okay.